Advanced functions. We'll be teaching you about advanced functions today. Domain and range. Domain is the highest x value subtracted by the lowest x value. Range is the highest y value subtracted by the lowest y value. Increasing, decreasing, and constant. In an increasing, the lowest y value should have a lower x value than the highest y value, like that. In a decreasing, the lowest y value should have a higher x value than the highest y value, like that. In a constant, either the x or the y will always stay the same. So going straight up or straight across. Okay. Even and odd functions. To determine algebraically if a graph is even or odd, plug in negative x for x and simplify. If the expression is the same as what you started with, it's even. If it's as if you multiplied the starting expression by -1, it's odd. If it's neither the same or the opposite, it is neither. This is what an even function should look like, and this is what an odd function should look like. In an even function, either both sides will be facing up or both sides will be facing down. In an odd, they'll be facing opposite directions. End behavior. If the degree of a polynomial is even, then the arms of the graph are either both up or both down, like that. If the degree is odd, then one arm is up and one is down, like that. If the leading coefficient is negative, the right arm is always down, like that. Absolute value functions. In an absolute value function, it will be represented by f of x equals the absolute value of x. This should make a right angle. Square root and cube root functions. As you can see, the square root function can be represented as f of x equals the square root of x. And the cube root function is f of x equals x cubed. Any function that can be written as f of x equals k times x to the a power is a power function. State the power and constant of variation for the function and graph it. Piecewise functions. Piecewise functions have two parts. For example, take this function. F of x equals x minus 2 when x is less than or equal to 0. F of x equals x plus 3 when x is greater than 0. It can be graphed like this. Okay, it's going to start at 3, because x plus 3 when it's 0. But it's going to be an open dot, because x is less than 0 doesn't include the function 0, or the value 0, it just goes up. But down here, when it's x minus 2, it's going to be a solid closed dot because it's less than or equal to 0, and we're on the 0. Greatest integer function. Greatest integer function of a real number can be represented as this. For all real numbers, it returns the largest integer less than or equal to x. Right. Inverse variation. In a graph of inverse variation, if the x is increased, then y decreases. If the x decreases, y increases. We say that y varies inversely with x, as you can see here. Solving rational equations. A rational equation is one where at least one term is fractional. When solving, cross-multiply first, then solve for x. After, check the answer by substitution and work the expression as an equality. So take this. 4 over x equals 9 over x minus 2. So you cross-multiply, and you get 4 times x minus 2 equals 9x. So if you simplify that out, and then you subtract 4x from each side, you have negative 8 equals 5x. And then you solve that, and you get x equals negative 8 over 5. Transformations. F of x plus k will move up by k units. And notice that k is outside of the parentheses. If k was inside of the parentheses, it would be represented as h, in which case it switches. So x minus h moves right instead of left, and x plus h moves left instead of right. And also here, again, outside of the parentheses, it's going to move down by k. And that's all.